Hi again and welcome back to the Programming and Coding Basics with VBA, Python and Java with JavaScript, brought to you by QuadRoot R&D. If you haven't subscribed to the channel yet, please do so for updates on future videos for this course, intermediate programming, data science and a lot more. Today we're going to get to the exciting topic of control flow statements, also known as conditional statements. So this is where we add some intelligence to the program. What we've covered so far, we can now write programs with mathematical operations, and I did mention towards the end of the last video that we can use the full power of logical checks using control flow statements. Now there are two kinds of control flow statements. One is loops and the other branches. Now branches are also known as if-then-else statements. Now usually it's done the other way around in other programming courses. It's branches first and then loops, but I thought I'd do it this way because it's in order of increasing intelligence. So far we have seen how to do basic mathematical operations, and now we can see how we can control the flow of the program by deciding where the program goes. Now the original control flow statement in older languages was the go-to statement. That is not a good idea anymore. With the go-to statement, the code became very difficult to read and became very unstructured. Whereas using loops and branches, you can completely avoid the go-to statement. Hence, I will not be using that, even though it still exists in VBA. Now, loops are exactly what it sounds like. It's looping an operation. So it asks the computer to repeat an operation, but it does so until a condition is met. And that's where we use the logical operators or the logical checks. Now with branches, you can direct the program to go one way or the other depending on the condition. So if one condition is met, then you go this way. If another condition is met, then you go that way. If another condition is met, then you go the third way, and so on. We'll reinforce the ideas with using examples. For loops, there's an example called Guess the Number Game. And for branches, I've made a simple wordy weather app as an example. So let's get right to it. So loops, as I mentioned, it's used for repetition. It repeats statements more than once. Now statements can be certain operations, or there can be some functions which we will discuss in the next video. Now it's called a loop and it needs a stop condition. That is, the program will continue to loop until some condition is met. And this is the algorithm for a loop. So it checks for a condition. If it's true, it does the operation, the loop operations, and then it returns back to check the condition. If it's still true, it continues doing the loop operations until it is not met, and then it exits out of the loop and then continues on. Here are some different ways to write loops. Now there are something called as the for loops and do loops. So there are two kinds of loops essentially. In Python there's no do loop, but there's a while loop. And in Java there's for each and while. While is very similar to the do loop in older languages and in VBA. There's a subtle difference between the for loop and the while loop or the do loop, and it helps to understand them to know when to use which. Now, when you know how many times you want to loop an operation, then it's pretty straightforward. You can use the for loop. Imagine a loop like a personal assistant. So as I said, loops are the next level of intelligence, where you ask your assistant to do something till a condition is met, or, for example, file all the reports on the table. And there is a finite number of reports. Say you know how many reports are there. Say there are 50 reports. So you ask your assistant to file the 50 reports. From 1 to 50, file them up. Now if you don't know how many reports are there, then you ask your assistant, file the reports till they are finished. Then your assistant will check if it's finished. Or you could make it even more complex. You can say, file the reports until pink forms are reached. So if it's still a condition is met, then you use the do until or do while. So the for loop, you specify it as for a variable name equals to 1 to y, where y is a known number. I've put it into a variable. You could even put a number here. Now sometimes you get that number from finding out the length of an array. Suppose you want to do something for an entire array, and remember, array is a collection of elements. Then you specify the length of that array. And then you end the for loop with the next x, or the next variable. So everything, all your operations come in between for and the next. In Python, the same for loop is represented as for variable in range y, and then colon, which signifies that everything after that has to be indented. So what it'll do is that from the starting value of x till y, it will do the operations. Now if you've initialized x as 1, then it will start from 1 to y, whatever the value of y is. Then you can put whatever operations below that as long as it's indented. And once you finish it, then you can come back to the line of for, to the level of for. So that's the for loop in Python. In Java and JavaScript, you use for, open parentheses, and now in these parentheses you specify the condition. In this case, you start with x is equal to 0. So now we assume we're going through an array where the first position is 0. X is less than y, where y is the length of that array or the maximum number. And you can see here that there are semicolons, which semicolon stands for the end of a statement. So this is one statement, this is another statement, this is another statement. So it's saying start with x equal to 0 till x is less than y, and from 0 to y you increment by 1. And if you remember, x plus plus is incrementation by 1. And so this is how you specify the for syntax. And then you open the curly brackets, and all your loop operations will be between these curly brackets. Now the do loop is you say do until x is equal to z. Say z is another number. Or you can say do while x is less than z. Now the difference between do and for is it need not increment. Now the for loop automatically increments in both cases, in Python and VBA. But in do loop, if you want to increment, then you have to actually increment it within the do loop. Else, it need not be an incrementation kind of loop. It need not be from 1 to 10. For example, you could have a set of 100 numbers, and they're all randomized. They could be anywhere from 1 to 20. And so your first number could be 1, and your second number could be 5, third number could be 3. And as long as it's less than, say, 10, it continues. And now you end a do loop with the word loop. So everything between the do while or the do until the loop is your loop operations. And you can have a number of operations, not just one. Now in Python, you have the while operation. So you say while x is less than z, which is your condition, or less than equal to z, you do everything else that's indented. Once you finish the operations, you can come back to the level of while. And in Java and JavaScript, it's while x is less than z, and then everything in the curly brackets is executed. Now, instead of do until, I've included the for each function or method. And so if x is an array, you can say for all the elements of that array, perform another function. So this is a special case problem where you can use a function. So instead of writing your operations, your loop operations between these curly brackets, you specify another function altogether. So this is mandatory. You cannot put operations in this for the for each. You have to put a function. And a function is basically a mini program, which we will be discussing in the next class. So the for each is basically, it will do for each element inside an array. And then it will perform a function. Suppose you want to double all the elements of an array, and the function doubles every element of the variable x. Now here's an example of the mastermind game using loops. We'll go through this quickly. Now we open the program, we named it guess the number. So essentially this is basically the computer thinks of a number and you have to guess it. And if you got it right, it will say correct. If you've not got it right, it'll say guess again. So now we have two players, and so we'll name them as our variables. So dime computer as integer, and so this is the number thought of by the computer. And dime player as integer, this is the number thought of by the player as the integer, or input by the player. So the computer has to think now. How will it think? So there is a function, built-in function called random. So we use the random function to get a number between 1 and 10. And we specify that we want it as an integer. So we use the int function here. The random function generates a number, a float number between 0 and 1. So it could be 0.56. And then you multiply it by 10. If you want a number between 1 and 10, then say it thought of 0.56 into 10 is 0.56 into 10 is 5.6. And then you say plus 1. So that's 6.6, and then you integer it and it just becomes 6. So the computer has thought of now 6, and the player is an input box where you're asking. Now I've used the word application here because sometimes VBA requires the word application to call its functions. And so we've prompted the user to guess a number between 1 and 10. And so whatever the user enters, that will get stored in the player variable. And then we put the do while function. And everything between do while and the loop is indented. Now this couldn't fit in the same line, so it went to the next line, but this was all in this line, indented. So we're saying do while computer is not equal to player. Remember, this is the not equal to, and this is how we use the logical check that we covered in the last video in a loop. So do while computer number does not equal player's number, and then you say player equals guess again. So basically it's telling the player through an input box, guess again. So as long as the player is wrong, it will just push out guess again. But if it's right, then it will not perform this operation. It will skip and then go straight to message box well guessed. And it's the end of the program. It ends there. Very simple game. You can do the same in Python, but in order to use the random function in Python, you have to import it from a library. Now, a library is a collection of functions, and we'll discuss that a little bit more detail in the next video. So here, the computer number is equal to random.randint between 1 and 10. So this is the library, and then we call the function, built-in function called randint. It's a random integer between 1 and 10, and 0 decimal places. And the player is an input. We prompted guess a number between 1 and 10, and we integer that number just to make sure that it's an integer, and we store it as an integer in player. Then we say while computer not equal to, and this is the format in Python and in Java. So it's computer not equal to player, colon, player is equal to, guess again. If not, if it is equal to, then print well guessed. And that's the end of it. This is in line of the while command. Now in Java, we start the public class, guess the number, and everything between the parentheses. And then we have our first main method, as in the previous class. And then within this method, we initialize computer as an integer, and we use the math.random function. And we'll discuss this in more detail in the next video when we discuss functions. So we want a random number between 1 and 10. This is how we do it. And we ask for the first guess. System.out.print guess the number between 1 and 10. And then we take in the user input in the while loop. So while integer.parseInt of, so parseInt is another function to convert a number into an integer, or to force a string into an integer. And this is the function that we saw last, which was system.console.readLine for inputs in Java from the console, is not equal to computer. So while whatever is input by the player, so we've not even now used a variable for player, we've just directly used this. So it's not equal to player, then use system.out.print guess again. Else, and this is the operations in the while loop. Else you print well guessed. So it's pretty straightforward. The most efficient seems to be Python in terms of the number of lines of code, but pretty similar except for the syntax. So hopefully you've got an idea now of loops, which are basically doing things a number of times in case of for loops, or in case of while loops, doing things a number of times till a condition is met. So let's move on to branch statements, or what is also known as if then else. So they are used for selection. It selectively execute a set of statements. It's called a branch conditional statement, as it redirects flow of code based on conditions in the form of if, then, else if, else, and end. So this is the algorithm. If a condition is met, and if it's true, then you do the then operations, and then you end. However, if it's false, then you do the else if operations, and you don't do these, you just do these, and then, oh, what else? If that is also false, then you do the else operations. Now you can have a number of else if operations. So you can say if this, then true, else if this, else if one condition, then do this, else if something else, else if something else, else if something else. If none of those conditions are met, then you finally come down to the last else operations and you end. So all these are in the false side of the original if condition. So you can perform multiple operations in each case, or redirect to another function or module. So it need not be operations, you can redirect to another function, and after that function is complete, it will come back here and then go back up and exit the code once it ends. Now you can have multiple if conditions can be nested within an if condition. These are called nested ifs, enabling complex decision making process. So think of it as a dream within a dream, like the movie Inception. So if these operations are done, then you can have one of these operations could be another if condition. And that is true, then you go to those and then operations and then end there. or if not, then you can have else if and else if and else. And so it can get pretty complex. So this is how you can make a decision tree algorithm. So a lot of pseudo-intelligent codes are essentially using a lot of conditional branch statements and nested ifs. Now, if you have a straightforward lookup, then you can make your code more efficient by using the case select statement. So if there are multiple cases or lookups in the form of select case end, for example, if there are only there's one option for every case, that's like reading a table. So from 0 to 10, do this. From 10 to 20, do this. From 20 to 30, do this. From 30 to 40, do this, and end. So it's a very tabular kind of structure. So you can do that with the if condition. And in fact, in Python, this is not available. It's available in VBA and in Java, in JavaScript. However, if this is available, then this is more efficient if it's in this format. Else, you can use the if condition. So we'll see how the syntax works in the example in the next slide. So the if, else if, else, end if is the first kind of statement, and the lookup or select case is the second kind of statement. So you specify it as if a condition is met. Now this is where we use our boolean, equal to's, and our checks. So if x equals to 0 or whatever, then do something in between these statements. You indent it, and you can have a number of operations. You can even redirect to a function. And then, but if this is not met, then it goes to this code. So if x is less than 0, if it's negative, then do these. But if it's not negative, then it'll go to the else condition. And it'll do everything is under else. So it doesn't go through all the code. It first checks this. If it's not true, then it'll go to this and it'll skip all that code. If this is not true, then it'll skip all this code and it'll go to the else. And it will do the else. If you don't put an else condition, then it'll not do anything. It'll just go to end if. So if none of the conditions are met and there's no else, then it'll not do anything. It'll just skip. Now in Python, it's if x equal to 0, colon, and everything else indented below that. Elif, so instead of else if, it's called elif, different condition, negative, then do these operations, else, colon, to the next operations. And then you come back to the same level to end your code. It's always better to keep a line space, but it's not mandatory. Now in JavaScript, you specify it as if in brackets, in parentheses, x is equal to 0, then, or whatever condition. Then you open the parentheses, the curly brackets, and everything between these curly brackets is your if condition. If this condition is not met, then it goes to the else if with the space. And then now it checks for negative numbers and then does everything between these parentheses, between these curly brackets if it's negative. If it's not negative, then it goes to the else and it does everything in this. But if this was true, then it would do only this and then go straight to the end. It would ignore else if, and else. Same as here. Now the select case is, the first line is you select the case and then you specify the condition and you do all your operations, and then for each case you specify case 1, case 2, or case, whatever the case you're checking, or each case will have a conditional check. So you can, for example, you can say select case X, And then you can have, say, case less than 0, case 0, case greater than 0. So you can have 3 cases and what the result of that case is. And we'll see this code in detail in the next slide. And then you have the else case if none of those conditions are met. And then you have the end select to close that. In Java and JavaScript, you use the switch X and then case N and then whatever is after case N. And you can have multiple cases, case N, O, P, Q, whatever. And then you break if towards the end, and default is your else case. So this break comes in each case. You have to include the break in each case. So break tells it to skip the remaining codes and come out of this switch. You can also have a break in the while command in the loops to come out of a while loop in both Java and JavaScript and in Python. So let's look at this example that I've thought of to reinforce the branches. Now I've thought of this wordy weather app when you have all these devices that you can speak to, which I can't name for legal reasons, but you ask that device, what's the weather like today? And the device answers you in numbers. Oh, it's so and so degrees and the wind speed is so much and it's going to rain. What if you were traveling and you couldn't, what if it was not in your units that you're used to? What if the device just spoke in words and say it's going to be a hot day today and windy and dry? So basically this app then converts all the numbers into words, into sensible words. So here are examples of that, code examples in VBA and Python. I didn't include Java because of space constraints. So I've named the app as what's the weather like, and you can see the comments here to signify the algorithm. First I've declared and initialized the variables. Then for the inputs, I've assumed that we read it from an online API or a database. So I've not included the inputs here because this is a complicated way to get inputs, and so that will be covered in my intermediate level course. When you read from databases or from some website online API. So I've hard-coded some values during initialization, and we'll use those as the inputs. And then you have our branch operations, and then you have the output at the end. So let's go to the declaration and initialization of variables. So I have 3 numerical variables and 3 word variables. So my numerical variables are temperature, wind, and rain, or temp, wind, and rain. And temp is a single float, so decimal numbers. Wind is a single float, and they signify Celsius degrees and miles per hour. And rain is a boolean, which is either true or false. It's going to rain or not. So I've initialized this. I've initialized temperature as 15 degrees Celsius, wind as 10 miles per hour, and rain as false, which means it's not going to rain. Now the word is temp word based on the temp, wind word based on the wind, and rain word based on the rain. And I've initialized rain word as dry and the remaining as empty. So we'll skip the inputs. We'll assume that we get the temperature in Celsius degrees and the wind in miles per hour and the boolean rain true or false from a database, and we put them into these variables. So then we go straight to the branch operations. Here I've used the select case because this is going to be a straightforward range selection, So if it's between certain degrees, then we'll use this word. So I'm going to be looking at the temperature, the value of the temperature, and then based on the conditions, I'm going to assign the word for the temperature. So case is greater than 35. So temperature is greater than 35. Then I use the colon and I say temp word equals to boiling. If it's between 30 to 35, temp word equals to hot. 25 to 30, temp word equals to warm. 20 to 25, temp word is pleasant. 15 to 20, temp word is cool. 10 to 15, temp word is getting a bit chilly now. And between 2 and 10, the temp word is cold. And else, which means if it's less than 2, then it's freezing. And then we end select. So this is the case else. So you've noticed here I've used a number of methods. You can use the is greater than, or we could have not kept temp here and we could have repeated temp all the way. We could have made case temp is greater than 35, or we could use the or an and condition. We could have said case temp is greater than 30 and temp less than 35. So we could have done it multiple ways, but we already had this too, so I've used that. And so this is the conversion of the temperature into a word. Now for the wind, I've used the plain if, else, if, and else. So if the wind speed is greater than 30, then wind word is equal to windy. Else if wind is greater than 15, then wind word is equal to breezy. Else, so if it's less than 15, wind word is equal to calm. Now a thing to note over here is you see that 25 is repeated over here twice. So if it's 25 degrees, which will it choose? Well, it chooses from top to bottom. So if it encounters 25 here, then this is the case it's going to select, and then it's going to come out of it. It's not going to run these statements. So these are going to be ignored. So it just runs till the condition is met, then it exits the case select. So the same way here. So think about that when you're ordering your ranges, because know that once it reaches a number, it's just going to go out of it. So here we say greater than 30, then greater than 15. So if it was 45, that is also greater than 15, but it's not breezy. It would stop here. It's greater than 30, windy, and then it goes off. So if it did go to the next one, then this would have also been true. But no, it does not perform the else if the if condition is true, and it just goes out. Now here I've put an if without an end if or an else condition, and you don't need an else and end if you have only a certain condition, if you have only a single condition. So if rain equals to true, then rain word is equal to wet. Else, it is already initialized as dry, so we don't need an else condition. So it's already dry, but if it's true, then we change it to wet. So great, now we have the words. So we can output message box, in our case, temp word and in, and I've concatenated, and I've put a string of comma space, concatenated wind word, concatenated again in quotes space, and rain word. So temp word for 15 degrees is 15, cool. Wind word, so it's going to be cool, comma, space. This is 10, so this is going to be calm. So it's going to be cool, space, comma, space, calm, space, and space. Rain word is dry. It's going to be dry. So cool, calm, and dry is what we expect. And it ends there. So what's the weather going to be like today? Cool, calm, and dry. Great. So now in Python, I've basically took this code, copied it, pasted it, and then edited for Python. And so the only changes was I had to remove the dime and as single, basically these left bits, and I just left the right bits. Converted to lowercase because Python only accepts lowercase symbols. Converted all the double quotes to single quotes. I then made sure I indented it. Basically there's no case select, so I converted it into if, elif. So I had to do the greater than logic. So once it reaches 15, it then exits here and then continues to the next one. I left a space here. There's no end if, just leave a space. And for true, now this is where I forgot to do this, and then during debugging, I remembered, oh, I had to put a double equal to sign. So if rain double equal to true, rain word equals to wet. Notice the row underscore convention I've used here. Left a space, and then output print in brackets temp word plus is the concatenate comma space in single quotes win word plus space and space in single quotes plus rain word. And that should be the end of it. There's no end program statement. So with that, we will stop here to appreciate the simplicity yet the power of conditional statements. In the next video, we will finally discuss functions, and that'll be our last theoretical class. And we will then walk through an example of the algorithm and the code for a game called Mastermind in the following class. So if you've reached this far, please like this video. Don't forget to subscribe and share it with your friends. See you in the next class.